Alright, in this video we're going to talk about piecewise functions, that is, functions that are split up into multiple parts or pieces. Alright, we're just going to take a look at two very basic functions, y equals 3x minus 2, y equals x squared plus 3. We're going to graph these simultaneously on the same coordinate plane. Okay, here are the two functions graphed simultaneously, but the problem with this is if we wanted to somehow merge this into a single function, it fails the vertical line test. So what we're going to do is we're going to split this up into two pieces so that it does define a function. So here's my plan. When x is greater than or equal to 1, I only want to use the one in red. And when x is less than 1, I only want to use the one in blue. So the result then looks like this. You can see that if I were to continue the blue one, it would look something like that, which would be the rest of the blue graph from the beginning, but I don't want that to happen when x is greater than or equal to 1. I only want to use the red one. Similarly, when x is less than 1, I only want to use the blue one. And so now the vertical line test works and everything is happy. Notice that I have an open circle as well for the blue one, and that's because I do not want to include 1 when I'm using y equals x squared plus 3. And so the resulting functional rule then, if this is my function f of x, then the equation looks like this. And we read this as follows: f of x equals 3x minus 2 when x is greater than or equal to 1, and it's x squared plus 3 when x is less than 1. Alright, so let's try a quick example just to make sure we get the idea. We're going to graph this function that's piecewise defined, and we're going to state the domain and range. So just to kind of set this up for you, everything to the left of this line, x equals negative 2, is going to be piece number 1. In between x equals negative 2 and 1 is going to be the second piece, and then finally everything to the right of 1 is going to be the third piece. We'll get into the greater than or equal to's and all of those kinds of things in just a minute. So here's the first piece. Here's the entire thing regardless of what area it belongs in, y equals 2x minus 3. But we only want to go for values that are less than negative 2, which means we're not going to include negative 2, and we're only going to go to the left of that first dashed line. So we're going to get rid of the part that's to the right of that first zone. We're going to have an open circle where the blue graph meets x equals negative 2 because it does not include, and we're only going to go to the left. So piece 1 is now done. Now we're moving on to piece number 2, which is going to be y equals 1, but again we're only going to go from negative 2 to 1. So we're going to include negative 2, but we're not going to include 1. And so when we're done, that's what we're going to end up with, and piece 2 is now finished. Finally, we're going to graph the third piece, y equals x squared. This is what it looks like regardless of what zone it belongs in, but it should be only greater than or equal to 1, which means 1 is included. So look what happens right here. The line is passing through that open circle, so this circle is going to get filled in, and then it's going to continue this direction, but everything else needs to get erased. So now that we're all finished, this is what the graph looks like. And again, I hope I've made this clear. This is basically a connection right here. So the whole thing looks like a little zigzag there and hole there, like so. Okay, so now all three pieces are done and the graph is finished. Finally, we're asked to state the domain and range. I've labeled a couple of locations on the coordinate plane to help you understand how to get the range, which is definitely the trickier of the two. The only y values that are covered is everything negative up to negative 7, but not including, and then from 1 to positive infinity going the other way. Okay, so hopefully this helps you understand piecewise functions, and that's it for today.